So today's daily challenge is problem number 2038, which is saying that remove colored pieces if both neighbors are of the same color, right? So basically here what we are given is that we are given a string and every character in the string is representing a color. Okay, color A and color B ideally. So what we have to do is we have to remove the characters that has a left and the right neighbor of same color. For example, if you take these three characters, the character at index 1 has a neighbor on index 0 and index 2, and all three of them have the same color, so this one can be removed. Same with the case of B. If at all there were three B's here, this one could be removed. But how this is happening, so let's try to read out once. So there are n pieces arranged in a line. These are n pieces arranged in a line, and each piece is colored either by A or B. Okay, we have either A or B. You are given a string colors of length n. So we are given this colors string and it has certain length which is denoted by n, where colors of I is the colors of ith place. Okay, so there are two people, Alice and Bob, and they are playing this game wherein they are taking alternative turns and they have to remove pieces from the line. Okay, they have to remove pieces from this line, and Alice is taking the first move. And what is the rule of this game? That Alice is only allowed to remove piece colored A if both its neighbors are colored A. Okay, and Bob is only allowed to remove a piece if it is colored B, also if both the neighbors are also colored B. So Alice will remove A, but she cannot remove B. Okay, Bob can remove B, but he cannot remove A. This is the rule. Also, Alice and Bob cannot remove pieces from the edge of the line. Okay, from the edges they cannot remove. They can only remove from first index to length minus 1 index. Okay. Now, this line, this rule: if a player cannot make a move on their turn, that player loses and the other player wins. Okay. So let's look at the example over here. Also, what do we need to return? Assuming Alice and Bob playing optimally, return true if Alice wins, or return false if Bob wins. Okay, if Alice is winning, we have to return true. If Bob is winning, we have to return false. So what this means is that the last chance was of Alice. Okay, then we have to return true. If the last chance was of Bob, we have to return false. Let's try it and try to understand these example cases. So here we have triple A, B, A, double B. So the output is true. How? Because Alice will move first and she will remove the second A, which is this one. Now the updated string is without this character, so it will be double A, B, A, double B, and the turn now is of B, Bob. Okay, but Bob cannot find three characters of same color, right? So Bob cannot make a move. So the last move was made by Alice and she was able to remove one character, so she wins. Okay, so that's why we are returning true. For this one, Alice will move first, make her move first. She cannot make a move because there are only two characters. They are A, but you cannot remove the edges, right? Now Bob will make the move. Bob also can't make the move, but the last turn was taken by Alice, so Alice will win here. So this is the catch here. So we are returning. Okay, no, it's not like that. So last turn was taken by Bob, so Bob will be winning at this point, which means if you see, if both have one chance of if both are making one move each, the last one is winning, which is Bob. So let's say if there were two chances for each of them, in that case also Bob would win. So from this we can draw some observation. Let's look at example number 3. So it is A, triple B, triple B, single B, and then triple A. So Alice will make a move. Alice will remove this A. Now Bob will make a move. Bob will remove, let's say from here B. Now again Alice will make a move, but this time there is no triple A together. So Alice can't make the move. Next is Bob's turn, and Bob's will definitely make a move. Actually, when Alice can't make a move, At that point only we can declare that Bob is the winner. Okay, because Bob has more chances of winning in the future, I mean making the move in the future. So if you read this out, Alice moves first. Her only option is to remove the second to last A from the right, which is correct from this one. Next is Bob's turn. On this updated string, he has many options. Okay, he can remove any of this, either this one or this one or this one or this one. He has many moves. Now on Alice's second turn, she has no more pieces than she can remove. Thus Bob will win. So return false. So this is actually making some sense now, because what we understand from here is that if the number of moves are equal for both Alice and Bob, then the latter wins. Latter means the Bob wins. If the number of moves are greater for any of the candidate, then that candidate wins, right? So initially I did this with this naive approach, brute force actually, I wherein I'm trying to loop through the string and trying to find the three indexes that are having the same characters. Okay, and then, you know, updating winner as per the current index. But this is not very optimal one. Okay, if I try to run and show you, this is passing the test case, and even if I try to submit, this is taking too long, and for some cases it's not passing. Okay, only 67 test cases passed out of 83. So obviously this is not a right approach. So the other approach that we can take is based on the observation that we made right now, that let's not do it turn by turn or make it alternative. What we can simply do is we can keep track of number of moves that each player can have. If it is equal, we'll declare Bob as the winner. If the number of moves is greater for any of the candidate, then in that case that candidate wins. Okay, so let's just try to just remove this real quick. Okay, so here what we need to do, we need to keep two counters that will be tracking Alice and Bob's scores. Okay, so let's say that Alice score is 0, and we definitely initially they have a score of 0. So then we have a Bob score which is going to be 0 again, and now we are going to iterate over the colors string. Okay, and since we are now going to remove the indexes at the edge, so we'll start it from the first index and end it one before the end of the length. So that is going to be less than colors dot length minus 1. Yeah, now let's take the current color. What is that current color? It is colors dot char at the ith index. Then let's take the previous color, which is going to be caret I minus 1, and actually the same thing, but it will be plus 1, right? Next color, yeah, it should be color. So we got the track of these three colors. Now we need to check if it is A or B, right? If it is A, it is, we have to increment it for the Alice score. If it is B, we need to increment it for the Bob score. So we will check if current color is A and previous color is also A and next color is also A. In that case, we need to do the Alice score plus plus, right? And same thing we need to do it for Bob as well. simply we'll change this A to B and this to Bob. Okay, and ultimately we are going to return whoever is greater. So return, so if Alice's score is greater than Bob's score, it will return true. If it is not, okay, in case of equal to also, it's gonna return Bob's score, so which is actually this will be evaluating to false. So this is the idea over here. Let's try to run. Current color has to have C capital. What is the error? Current, okay. hmm yep. So this has finally solved, and yeah, you could have seen that it might have sounded a little, too much of code, but yeah, it was done so easily just because of these observations that we made. So yep, see you tomorrow now. Thank you for watching, and if you have any feedback, please leave it down in the comments below. I'll try to improve the video quality or anything else you need. So yeah, definitely let me know. Thank you.